Hello, wonderful people. It's Medicosis Perfectionalis, where medicine makes perfect sense. Welcome back to my physics playlist. In previous videos, we had an introduction to physics. We talked about scalars versus vectors. We talked about distance versus displacement. Today, let's talk about speed versus velocity. Speed with an S is scalar with an S, but velocity with the V is a vector with a V. What does a scalar quantity mean? It means it has a magnitude only but no direction. But velocity is a vector, meaning it's a quantity that has a magnitude and a direction, which means velocity could be a positive number or a negative number, but speed cannot be negative. Speed is the rate of change in distance, but velocity is the rate of change of displacement. Time is a fundamental quantity, it's not derived from anything else. Length is also a fundamental physical quantity. However, speed is derived from distance and time. Similarly, velocity is derived from displacement and time. Click the like button, click the subscribe button, and let's get started. This video is part of my physics playlist. Please watch these videos in order. Quick review: scalars versus vectors. Scalars have a magnitude only, but no direction. Vectors have both a magnitude and a direction. Example of scalar quantities include distance, time, speed, temperature, pressure, work, mass, area, energy, and volume. Vectors include displacement, velocity, torque, acceleration, momentum, force, electric field strength, and weight. So distance is scalar, displacement is a vector. Speed is a scalar, but velocity is a vector. Speed equals distance over time. When you divide a scalar by a scalar, you get another scalar. But velocity equals displacement over time. When you divide a vector by a scalar, you get a vector. Let's review. Adam again walked from -3 to +2, and then from +2 to -1. Calculate the distance and the displacement. Let's go. So first from -3 to +2, right here, how many units? Here's 1, 2, 3, 4, 5 units. Then from +2 to -1, like this, how many units? 1, 2, and 3. Distance is scalar, does not have a direction, so you just add them together. 5 plus 3 equals 8 meters, that's the total distance. How about the net displacement? Now this one has a direction, so to get the displacement, let's call that delta x, you need the final position minus the initial position. What's the final position? Adam ended up at -1, that's the final, and minus the initial position. What's the initial position? It is -3, so minus -3 or -1 plus, which gives me +2. Displacement has a magnitude and a direction. If Adam started here and ended there, it is as if Adam was displaced 2 meters to the right. 2 meters in the positive direction. Distance, scalar, which means magnitude only, but displacement is a vector, which means a magnitude and a direction. From distance, speed is derived, and from displacement, velocity is derived. That was beautiful. So speed equals the change in distance over change in time, whereas velocity equals the change in displacement over the change in time. The rate of change of distance is called speed, but the rate of change of displacement is velocity. In the next video, you will learn about the rate of change of velocity, which is called acceleration. There are two types of velocity, uniform and non-uniform. Uniform could be also called constant velocity, but non-uniform is variable or not constant. Suppose that you're driving your car at a speed of 35 kilometers per hour. You're not changing the speed. You're not speeding up. You're not slowing down. This is called a uniform or constant velocity. Linear relationship between displacement and time. Conversely, let's say that your car started at 5 kilometers per hour, then 10 kilometers per hour, then 15, then 20, then 30, 35, 40, 45 kilometers per hour. Look at this. What's happening here is that I'm speeding up, which means my velocity is not constant. It is not uniform. Non-linear relationship between displacement and time. Displacement over time equals what, please? Well, it's displacement, it's not distance. So displacement over time is called velocity. Velocity. So when you have displacement on the vertical axis and time on the horizontal axis, what's the slope? The slope is velocity. Here the slope is linear because it's a uniform constant velocity. My car is moving forwards. That's why the line is going up and not down. Linear because it's uniform. But here, well, my car is still moving forwards. That's why the line is sloping upwards and not downwards. It is non-linear because it's non-uniform. If I measure the slope of this line right here and the slope of this line right here, they are exactly the same. But with the non-linear one, if I measure the slope of this line and the slope of this line, they are not the same. This one has a lower slope than that one because that one is steeper than this one. Because the two slopes are not the same, this is a non-linear relationship, making it non-uniform. So the definition of uniform velocity is that the object moves through equal displacement in equal time intervals. And the definition of non-uniform is that the object moves through unequal displacement in equal time intervals. Now, throughout this video, you will have tons of questions and problems to answer and solve. Please bring a sheet of paper and let's see how many questions you'll answer correctly. You can download these wonderful, colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Next, here's a question for you. This graph represents the relation between displacement on the vertical axis and time on the horizontal axis. From this graph, please find the total distance covered by that object, the net displacement, and the slope of that green line. Please pause and try to answer these yourself. To answer this, I would like to divide this graph into 3 lines or 3 colors. There is the green one, there is the orange one, and there is the red one. When you're going up like this, it means that you're moving in the positive direction. Then you moved in the negative direction, returning back to the 0 point that you started at. Then you kept moving backwards again. Fortunately, total distance doesn't care about the direction. You just add all of them together. So the green one moved from 0 to 150, so the total here is 150 meters. Then I moved back the same 150 meters, so let's write 150 right here. After this, I went back to square one, or square 0, I should say. Then I walked backwards, 50 and then 100. So that's another 100 meters right here. So the total distance is 150 meters plus 150 meters plus 100 meters for a total distance of 400 meters. But net displacement is different. It cares about the difference between the 0 point and what you ended up at, which is negative 100. So net displacement always equals the final point minus the initial point. What is the final destination? Negative 100 meters. And what is the initial one? Just 0. Making the total net displacement negative 100 meters. And that's the answer for the second part of the question. Okay? Third, what's the slope of the green line and what does it represent? Remember how to find slope? There are many ways to find slope. One of them is tangent of the theta angle. What's the theta? It's the angle that the line makes with the horizontal. This angle. Do I know how much is this angle? I do not know, so I cannot use tan theta. What else can I use? You can use rise over run. Oh, what's rise? The change on the y-axis. What is run? The change on the x-axis. So let's use all of this triangle right here. Rise, I rose from 0 to 150. So the rise is 150 minus 0. And what's the run, please? Well, from here to here, well, I went from 0 to 3 seconds. So it is 3 minus 0. Meters upstairs, second downstairs. 150 divided by 3 is 50 meters per second. Meters per second, meters per second. What's that? That's velocity. Why didn't you say speed? Because this is displacement. This is not distance. If this says distance, I will say speed. But if this says displacement, I will say velocity. Remember that displacement is a vector and velocity is a vector, so a better answer is positive 50 meters per second, and that's the slope of this line. The slope is positive because the line is going up like this. But if the line was going down like that, that will be a negative slope. And here are the answers again in color. Total distance, you just add this 150 plus this 150 plus this 100. You get 400 meters. The net displacement cares about the final destination, which is negative 100 meters, and the point of origin, which is 0. Negative 100 minus 0 equals negative 100 meters. Notice that distance is a scalar. It has a magnitude only but no direction. But displacement is a vector. It has a magnitude and a direction. The slope is rise over run. What's the rise? Displacement. What's the run? Time. Displacement over time is velocity. And then 150 minus 0, that's the rise. 3 minus 0, that's the run. This part right here is the slope of the green line, and you do the math, you find the slope is positive 50 meters per second. Let's create a table to talk about speed. So here is time measured in seconds, and here is, well, it's speed, so this is distance, not displacement, measured in meters. Now let's see, a car is moving. At 0 seconds, I haven't moved yet, 0 meters. Then in the first second, I moved 2 meters. Then at 2 seconds, 4 meters. 3 seconds, 6 meters. 4 seconds, 8 meters. 5 seconds, 10 meters, etc. Can you calculate the speed? Yes, I know that speed equals the change in distance over the change in time. So what's the change in distance? Let's look from here. This is my final point to here. This is my initial point. So the distance is this difference over 10 meters minus 0 meters. Over time, the time is the difference between 5 seconds and 0 seconds. So 5 minus 0 seconds like this, you end up with a speed of 10 meters over 5 seconds or 2 meters per second. Since this is speed and not velocity, I'm not going to say positive 2 or negative 2. I'm just going to say 2. What if instead of taking these 2 points as points of reference, let's focus on this point and that point. Let's calculate the speed. So what's the change in distance and what's the change in time? The change in distance is 8 minus 4, and the change in time will be 4 minus 2. 8 minus 4 meters is 4 meters. 4 minus 2 seconds is 2 seconds. 4 divided by 2 is 2 meters per second. Guess what? It's the same speed as above, which means it's a uniform speed. Uniform, yeah, not variable, not variable. It is uniform. It is constant speed, which means if distance is here on the y-axis and time is here on the x-axis, if it's constant speed, it's gonna look like this, a beautiful straight line going up. Straight line because it's uniform speed. Going up because I'm moving forwards. The distance is increasing over time. The slope is rise over run, or distance over time, which is speed. So the slope of this line represents speed. And this is what we see here. If you choose any points and then find the difference in distance and the difference in time, you'll find that the speed is always 2 meters per second. And then you draw the line like this. Here's my graph. Distance over time, which means the slope of this line is speed. How can I find the slope of this line? Well, it's the tan of this angle, but since I do not know the angle, I gotta use rise over run. The difference on the y-axis divided by the difference on the x-axis. Now let's change things a bit. Instead of saying distance, we'll say displacement. Okay. Then displacement over time is what? It's not speed, it is velocity. Displacement is a vector. Velocity is a vector because a vector divided by a scalar gives you a vector. As we have discussed before in the previous video titled Vectors versus Scalars. So how can we calculate the velocity? All right, let's choose 2 points. Let's choose this point and this point right here. Okay, I want delta x over delta t. What is the change in the displacement, please? It is 6 minus 1. And what is the change in time? It is 6 minus 1. 6 minus 1 is 5 meters. 6 minus 1 is 5 seconds, which will give me 1 meters per second. And this is positive 1 because velocity is a vector. And here's the graph. Rise over run will give me velocity. Let's take all of that big triangle right here to calculate rise over run. Rise, what's the maximum point? It is 10 from 0. So that's 10 on that numerator. And then in the denominator, 10 minus 0 is also 10. 10 divided by 10 is also positive 1 meters per second. This is a uniform velocity. It is going up in a straight line. Notice a little hint here. You see displacement? Yeah, that's a vector, and that's why you'll see a positive component and a negative component. But with distance, you only saw the positive component because distance is a scalar. You see what we've just talked about? We can call these average speed and average velocity. If you find these videos helpful, please support my channel by buying me a coffee. Go to buymeacoffee.com/medicosis. Thank you. But how about instantaneous speed and instantaneous velocity? Well, still, instantaneous speed is a scalar and instantaneous velocity is a vector. Both of these have the same magnitude. So the magnitude of instantaneous speed is the same as the magnitude of instantaneous velocity. Let's say that at this moment, I'm driving my car at a speed of 5 kilometers per hour. Okay, that's my speed as of this moment. What's my instantaneous speed? 5 kilometers per hour. And instantaneous velocity? Positive 5 kilometers per hour. Notice that the magnitude is the same, 5 kilometers per hour. To get the instantaneous velocity, we use limits. We use calculus. It is still the change in displacement over the change in time as time approaches 0. At this instant. So the magnitude of instantaneous speed is the same as the magnitude of instantaneous velocity. However, the magnitude of average speed is not necessarily the same as the magnitude of average velocity. Why not? Because the magnitude of average speed takes into account all the actual distance that you traveled. Let's say that you traveled 5 kilometers east and then 5 kilometers west. The average speed will take into account the 5 kilometers and the 5 kilometers or the 10 kilometers. However, if you do the same thing for velocity, well, velocity is different because velocity cares about what? It cares about the displacement. If I go 5 kilometers east and then 5 kilometers west, what's the net displacement? 0. So what's the average velocity? 0. Oh, so the magnitude of average speed is not the same as the magnitude of average velocity. Question. The Earth completes its orbit around the Sun in 1 year, traveling 9.4 times 10 raised to the 8th power kilometers per year. Please find the total distance in 1 year, net displacement in 1 year, average speed in 1 year, and average velocity in 1 year. Please pause. When in doubt, draw it out. Okie dokie, here is the Earth, and here's the orbit around the Sun until I come back to the origin. And all of that is how much? It is 9.4 times 10 power 8 kilometers per year. So I got the total distance. The total distance is this number right here. That's it. It is 9.4 times 10 power 8 kilometers. That's the final answer for the total distance. But careful, because they do not want the answer in kilometers, they want it in meters. How do I convert kilometers into meters? You multiply by 1,000. So instead of 10 power 8, it will be 10 power 11 meters. So let's write this again, 9.4 times 10 power 11 meters, and that's the answer for total distance. How about net displacement? I started here, I ended up here, so the net displacement is 0, zip. Next, what's the average speed? Okay, speed is not velocity. Speed cares about the distance, not the displacement. So it is distance over time. What's the distance, please? 9.4 times 10 power 8 kilometers. And what is the time? We said 1 year. But be careful, because they want the answer in meters per second. How do you convert kilometers into meters? You multiply by 1,000, like this, so that it becomes a meter. And then how do you convert 1 year into seconds? Well, I know that 1 year contains 365 days. That will give me the answer in days. I know that 1 day contains 24 hours. Each hour contains 60 minutes, and each minute contains 60 seconds. When you do the math, you'll find that the final answer is 29807.20 meters per second. If you want it in the scientific notation, it is 2.9 because you have this point moving like this. I moved 1, 2, 3, 4. So it's 2.98 times 10 power 4 meters per second, and that's the final answer for average speed. How about the average velocity? Average velocity is displacement over time. And what's the displacement? 0. 0 over anything is 0. And here are the same answers again in color. Total distance, net displacement, average speed, average velocity. Look at this graph. If you see displacement on the y-axis and time on the x-axis, what's the slope of this line? Well, the slope will be velocity, displacement over time. Since this line is not a straight line, it is a curved line. Would you call this uniform or non-uniform? This is uniform velocity. But let's say that the line looked like that. Oh, that will be uniform velocity. Uniform, non-uniform. For the uniform velocity, if you calculate the slope of this line right here, and the slope of this part right here, and the slope of that part right here, they'll be all the same. The slope here is the same as the slope there, is the same as the slope there, is the same as the entire slope here. All of them will be the same because the velocity is uniform. But for this line, if you want the slope of this line, and the slope of that line, and the slope of that tangent, they are not the same as you see. This one is not the same as this one, is not the same as this one. This one is the steepest, and this one is the least steep. This will be the lowest slope, and this will have the highest slope. Why is the slope here different from here, different from here? Because the velocity is non-uniform. Okay, what if this is displacement on the y-axis and this is time on the x-axis? And the line is not a straight line, it's a curved line. Would you call this uniform velocity or non-uniform velocity? Of course it's non-uniform because the line is not straight. And if you want the slope of this line right here, you want the tangent, okay? And then you create y component and an x component. The slope of this orange line is delta y over delta x, the change in the y-axis over the change in the x-axis. And this will give you a slope, let's say, of this number. However, if you repeat this to find the slope of this tangent, you will find a different slope. It will be another number. Why is that? Why is the slope here not the same as the slope there? Because the velocity is non-uniform. Now I want you to keep this number in mind, 5.6 meters per second. Now look, instead of instantaneous velocity, let's calculate the average velocity. If you want the average velocity, you have to take all of it into account from the beginning to the end. To get the slope of this purple line right here, where is my delta y? Here's the delta y. Where's the delta x? Here's the delta x. So the slope of this line, or average velocity, is delta x over delta t, the change in displacement over the change in time. The change in displacement is from 0 to 20, or let's say 18 because it's this point, so 18 minus 0. And time is 5 minus 0. Okay, what's the answer? 3.6, which is not the same as 5.6, which tells you that the instantaneous velocity is not the same as the average velocity if the velocity is non-uniform. But if the velocity was uniform, then the instantaneous velocity and the average velocity will be the same. Question: the slope of the straight line passing by the origin and which represents the relation between displacement on the vertical axis and time on the horizontal axis is what? Please pause and try to answer this yourself. Let's draw this together. So I need a vertical and a horizontal. What's my vertical? Displacement. And what's my horizontal? Time. And how is the relation? Well, it's a straight line passing by the origin. The origin, by the way, is 0 and 0. It's this point right here, the beginning, okay? And going up like this. It is a straight line. If it's a straight line, this has to be uniform. Uniform what? Well, did they say distance or did they say displacement? They said displacement, so it's uniform velocity. Why velocity? Why not acceleration? Because acceleration is the change in velocity over the change in time. So if this was v and this was t, that will be uniform acceleration. But this is d, displacement, and t, time. Displacement over time is velocity, so this is uniform velocity, making A the correct answer. Next, the rate of change of displacement at a given instant is called what? Well, let's break that down. When you say rate, it means time. The rate of change of something means that time is in the denominator. Of what? Displacement. So displacement is in the numerator. The change in displacement over the change in time, or the rate of change of displacement, is called what? It is called velocity. Velocity at an instant is called what? It's called instantaneous velocity. How about this one? The ratio between total displacement and total time is what? Is it instantaneous velocity, average velocity, variable velocity, or speed? Please pause and try to answer this yourself. Okay, so it's the ratio between what? Total displacement over total time. If it's total, then this is the average velocity. Remember, here is my graph. I have displacement here. I have time there. So d over t. And there's a straight line going up here. Remember, if you want the slope of the entire thing, if you want average velocity, you go from beginning to end. So this will be your delta y, and this will be your delta x. It's the ratio between total displacement and total time, and this is your average velocity, or v dash or v bar. Next, mention the physical quantities determined by the following relations. Total displacement over total time is what? Total distance over total time is what? Delta displacement over delta time is what? Pause and try to answer this. If it's total displacement over total time, then this is my average velocity. How about total distance over total time? That's the average speed. Okay, how about delta displacement over delta time? That's just good old velocity. This is very important. Please take a moment to pause and review. Next, please plot the graphical relation that represents each of the following. Here is this, and this, and this. Please pause and try to answer this. So let's draw a graph like this. I want a static object, motionless, using displacement over time relationship. Here is displacement, and here is time. You want it to be motionless. Motionless meaning the displacement is not increasing or decreasing. It is a straight line that looks like this. Next, we want to plot a moving object at a uniform velocity using displacement over time relationship. Well, it is moving, so the displacement keeps increasing and increasing and increasing. And it's moving at a uniform velocity, meaning the line has to be a straight line going up. Why is it going up? Because I'm moving forwards. I am not stationary. Why is it a straight line and not a curved line? It is a straight line because the velocity is uniform. Why is this velocity and not speed? Because this is displacement and not distance. See, physics makes perfect sense once you understand what the French toast you're talking about. I think I should rename my channel Physicosis Perfectionalis. Third, how about plot the relationship between a moving object at a non-uniform velocity using displacement-time relationship. First, let's draw the axes like this. I have displacement again over time again. What do you want today? I want non-uniform velocity. Non-uniform, okay, it is variable, you mean. So this is a curved line like this. If you do it like this, it means that the velocity keeps going up and up and up and up and up, i.e., the object is accelerating. It is speeding up. But let's say that I decided to draw it like this. Now, what does that mean? It means that I started up fast and then I'm slowing down and down and down and down and down until I become motionless, just like that. Again, take a moment to pause and review. This is a stationary, motionless, static object. This object is moving at a uniform, constant velocity. And this object is moving at a non-uniform velocity, speeding up like this, slowing down like that. Next, can you please describe the kinematic state of the object? Is this motionless? Is this moving? Is it moving at variable speed or constant speed? Also tell me about the slope of each line. What does the slope represent? Does it represent velocity, speed, acceleration, or what? Pause and try to answer this. In the first one, I have displacement and time, and the displacement keeps going up and up and up. So this is an object that is moving forwards, okay? So displacement is positive, that's why it's forwards, and at a constant or uniform velocity. What does that slope represent? It is the change in the y-axis over the change in the x-axis. Delta d over delta t is velocity, so this slope represents velocity. How about here? Well, displacement is there and time is here. Oh, and the slope is 0 because this is a motionless object. It is stationary, it is static. What does the slope represent? Also velocity. And the slope here is 0 because the velocity is 0 because I'm not moving. Third, how about that? Displacement over time. What's the slope? The slope is also velocity, but the line is descending, which means it's a negative slope. Why is it a negative slope? Some student will say, oh, the object is slowing down. No, because if the object is slowing down, the line will never be a straight line. If this is a straight line, it means that the velocity is uniform. It's a constant velocity, not a changing one. It's uniform velocity. So what's going on? Why am I decreasing? Well, is the time decreasing? No, the time is increasing from 0, 1, 2, 3, etc. Is the displacement decreasing? Yeah, it is decreasing. So maybe, just maybe, that you're moving backwards in the opposite direction at a uniform velocity. Ooh. And the slope is still velocity. Remember that velocity is a vector. It could have a positive sign or a negative sign. And last, how about this? Displacement over time, so the slope represents velocity. This velocity is increasing. It is non-uniform velocity. It is an accelerating velocity. Now pause and review. Here's the answer for A, the answer for B, for C, and for D. Another question. Objects A, B, and C have moved from rest. Which object is the slowest? Is it A, B, or C? Or they're all the same? Please pause. What's the answer here? Well, the slowest one is the line with the least slope, with the smallest slope. How do I know? Remember that the slope is tan theta, which means the angle that you make with the horizontal. So let's draw the angle of C in an orange color, and the angle of B in a green color, and the angle for A in a blue color. Here is the angle for C, small and tiny. Here is the angle for B, it's a bigger angle. And here is the angle for A. And what's the slope? Again, the slope of any one of them is tan theta, which is the angle that each one makes with the horizontal. Which one has the smallest angle? The one with the smallest angle is C. If C has the smallest angle, then C has the smallest slope. Why is this? Because if theta is small, then tan theta is small. You can do it on your calculator to practice. Try tan 10 on your calculator and see the answer. Then try tan 25. Then try tan 45 and see. You'll find that tan 45 is greater than tan 25, which is greater than tan 10. The bigger the angle, the bigger the tan of that angle, and the bigger the slope. Which means A has the highest slope because it has the biggest angle with the horizontal. B has a middle-of-the-road slope, and C has the smallest slope. If C has the lowest slope, then C has the lowest velocity, which means the slowest, making C the correct answer. Why is this? Because the slope is what? It's the change on the y-axis, which means displacement, over the change on the x-axis, which means time. Displacement over time is what? Is velocity. So the slope of each one represents its velocity. Here's the velocity for C, the velocity for B, the velocity for A. C has the lowest velocity because it has the lowest slope, because it has the smallest angle with the horizontal. Remember that when you're trying to establish the angle, it's the angle that the line makes with the horizontal, not with the vertical. So the angle for C is this angle right here. Please do not do it like this. Do not say, oh, this is the angle for C. No, it has to be with the horizontal. Next, the diagram that you see here depicts the relation between a car's displacement and the time. Please find the instantaneous velocity after 2 minutes, instantaneous velocity after 6 minutes, and average velocity after 8 minutes. This is a very important question. Please pause the video, try to answer this yourself. I'll be so proud of you if you can solve these correctly. Let's do it. Instantaneous velocity after 2 minutes. 2 minutes here, you go up. all right, I want the slope of this line. How do I get it? It's the change in the y-axis over the change on the x-axis. Y-axis is from 20 to 0. So 20 minus 0 meters on the numerator. And then what is the horizontal? It's 2 minutes minus 0, which gives me 2 minutes. So 20 over 2 minutes. But that will give me in meters per minute. But if I want meters per second, I need to multiply this by 60. Which gives me an instantaneous velocity of that line of this number right here, meters per second. Now, how about the instantaneous velocity after 6 minutes? Well, after 6 minutes, look at me. I am horizontal. So the instantaneous velocity at this instant is what? The slope is 0. I'm not moving. So 0 is the answer. Next, be careful of this one. Average velocity after 8 minutes. When they ask about the average, it's the entire whole shebang. You have to draw a line from the origin to the last thing in displacement, the last part of the line. So from this one to this one, you draw your line like this. Can you find the slope of that line? Sure, it is rise over run, the change on the y-axis over the change on the x-axis. The change on the y-axis is 40 meters minus 0, and the change on the x-axis is 8 minutes minus 0. Don't forget this 8 is minutes, so you multiply it by 60 to get the answer in seconds, which gives me the answer of a velocity of 0.083 meters per second. The last two questions are your homework. They are very important. Here is the first one. Please pause and try to answer this. I love this question so much. And here is an even more difficult question about the two sisters running towards one another. Please pause. The solution to both of these problems will be found in the next video that will be titled Acceleration, and you can find it in this physics playlist. Remember that the magnitude of instantaneous speed is the same as the magnitude of instantaneous velocity. But if you're talking about average speed and average velocity, well, it's not necessarily the same magnitude, is it? For example, the average speed by which the Earth rotates around the Sun is an actual number. But the magnitude of the average velocity of the rotation of the Earth around the Sun is actually 0 in a year. And you know that at the end of each video, we have to talk about the equations that we learned today. Okay, how do I get the total distance? The total distance is d1 plus d2 plus d3, etc. You just add up all the distances together. How about the net displacement? Net displacement is the final point minus your initial position. Next, instantaneous speed. Instantaneous speed, we'll use limits as time approaches 0, and you have here is distance over delta t. But how about instantaneous velocity? Well, again, you use limits as time approaches 0, and I need the delta x, this time is displacement, over delta t. You can call it delta x, you can call it delta d, I don't care, as long as you understand that this has to be displacement if this is velocity. Next, how about the average speed? The average speed is total distance over total time. And how about the average velocity? Average velocity is total displacement over the total time, or the total change in displacement over the total change in time. Notice that you can draw your line in the sand here. These are scalar quantities, but these are vector quantities. These have a magnitude only, but those have a magnitude and a direction. Please take a moment to pause and review and write down these equations in your own handwriting. The more you write them down, the greater the chance that you will remember them on your exam. Scalars versus vectors. Distance is a scalar, displacement is a vector. Speed is a scalar, velocity is a vector. In the next video, we'll talk about acceleration, also a vector. Because acceleration is the change in velocity over the change in time. When you divide a vector by a scalar, you get another vector. You can download my physics notes, general chemistry notes, organic chemistry notes, biochemistry notes, physiology notes, biology notes, all kinds of notes on my website, medicosisperfectionalis.com. I help you learn, understand, and pass exams. I do not just teach physics, I teach biology, general chemistry, organic chemistry, biochemistry, anatomy, physiology, pathology, immunology, pharmacology, and all of the ologies, except astrology. If you want to learn about your kidney function, the glomerular glomerular filtration rate, what happens in the proximal tubule, loop of Henle, distal tubule, etc., download my renal physiology course at medicosisperfectionalis.com. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, smash like, hit the bell, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.